All right, so part 2 of 4.1, Math 1, it's all about the rates of change. So when I ask myself, what is a rate of change? So what's a rate of change? You can think about it like this. It's basically a comparison of two different variables that are affecting one another. And it's a comparison using division. It's a ratio. So an easy way to think about it is it's a ratio. It's a fraction. You're basically comparing what's called the dependent variable over the independent variable. Usually the independent variable is time. All right? For instance, when you see this graph right here, it's saying that there were 13.3 million students in U.S. public schools in 1970. And then it talks about how it kind of moves along. This rate of change is going to compare the dependent variable, millions of students, okay, divided by how many years have elapsed, the number of years, right? So when you see a rate of change here and it says, what's the rate of change of public school enrollment from 1970 to 1990? What we're doing is we're saying, what's the fraction that compares 1970s data to 1990s data? So we're piecing these two together. So here's what you do. You say take the most recent ordered pair, so the one that's to the right, all right? Right here. 1990 corresponds to 11.3 million. We're going to put the 11.3 million in the top because this is going to be the dependent. The y's go on top, the x's go on the bottom, okay? And what you're going to do is you're going to say it changed difference. You're going to subtract 13.3 million and then divide by the difference in time. So 1990 minus 1970. I know this probably is a little bit overwhelming to start with, but I think you guys will get the gist of it with a few examples. So, dependent over independent. Y variables divided by X variables. And the rate of change ends up being minus 2 million students I'll just put ST for students over 20 years. So the rate of change is that we dropped 2 million students in public schools over that 20-year period. And sometimes what happens is you will reduce that fraction. So this could also be written as, the rate of change was the same as going down 1 million students every 10 years. And then sometimes people will want it in terms of a decimal. They'll say, okay, what's that decimal? Well, you're going to go down 0.1 million students per 1 year. So it's sort of like you're dropping 100,000 students per year. That's getting into a lot of things. Today, I just want you to be able to tell me that that's what's going on. Okay? So, let's see if we can take all of this information and make some kind of sense of number 4. Determine the rate of change of public school enrollment from 1990 to 2000. So what we do is we say, here's our data point, 1990. Here's our other data point, the year 2000. And we're saying the rate of change is going to be 13.5 minus 11.3 over the year 2000 minus the year 1990. That gives us 2.2, and it's positive, million students over a 10-year period. So yeah, that's the rate of change. Which tells the reader, oh, you're saying that we increased, for plus, 2.2 million students over a 10-year period. That's good information. Just like up here it said, whoa, you decreased 2 million students over a 20-year period. This was the answer for number 3. So if you see a chart like this, that's how you would deal. Okay, that's how you would write the rate of change. Let's check out number 5. So this chart represents the number of, you know how you do ratings inside of like a magazine or like a Yelp rating? It's like, hey, you get 1 star, you get 1.5 stars, you get 3.5 stars. Well, what we're doing is we're trying to see if there is a relationship between the number of stars a hotel gets and how much it costs. Because it stands to reason that the cheaper a hotel, probably the less, it probably doesn't get the greatest reviews from people. The more expensive ones, they're probably taking care of their customers. Maybe that's just a generalization, and I'll stop right there with that. So the first thing I want you to be able to do is create a set of data points, which is basically just saying, from a chart like this, you can create a set of ordered pairs. So the question is, who's X? Who's Y? And I guess, here's the thing. Right here, we're saying that the number of stars a hotel gets will probably affect the price, right? It's sort of like the number of stars is our time, and the average price in dollars is going to be is sort of like our dependent variable. So, the X, number of stars. The Y is going to be the average price. So you've got the data points X, Y, 160. 1.5 corresponds to 70. 2 corresponds to 85. 3 corresponds to 115. And then 3.5 corresponds to 130. So that's all we're saying right here is that if you get a set of data points in a table, they can be rewritten as ordered pairs. Now, where am I going with this? I want you guys to use these ordered pairs to determine rates of change. So remember, the rate of change is a fraction, and it's like, oh, what's the change in Y over the change in X? So what's Y's change divided by X's change? And they're saying we're going from 1 star to 2 stars. So who are the data points in question? It's this data point and that data point. So we're looking at 160 and 285. So recognize it like this. These are our X coordinates. I'm just going to call this X1, X2, okay? These are our Y coordinates. Remember, X left, Y right. This is Y1, this is Y2. So all you're doing to determine the rate of change is you're taking, if they're ordered pairs, Y2 minus Y1 over X2 minus X1. And you now can use this as a formula. Keep this as your rate of change formula. So we're going to do 85 minus 60 over 2 minus 1. You need to put your units on this assignment. So what did the 85 and 60 actually represent? Oh, they represented dollars. Remember? Dollars? Can you guys see that? Yeah, these are the y coordinates. The 85 and the 60 were dollars. So it was a change of $25 for every 1 star. Okay, so the rate of change between how much a hotel costs and how many stars it's given is $25 for every star. Now that's just using those 2 data points. What if we did letter C, where it changed from the very beginning, 1 star. Sorry, you guys can't see this. What a mess. Okay, sorry. What about part C? 1 star to 3.5 stars. So what you're going to do is use the ordered pair. 1 star corresponds to $60. 3.5 stars corresponds to $130. Correct? Yes. What's the rate of change from 1 star to 3.5 stars? Well, you got X's here. You've got Y's right here. The formula that you now have is the rate of change is equal to y2 minus y1 over x2 minus x1. 130 minus 60 divided by 3.2 minus 1. Okay, so 130 minus 60, that's 70. So $70 over 2.5 stars. Yeah. Now, I got a question for you. Can you rewrite this without decimals in the fraction? Because decimals inside of a fraction are kind of a no-no for mathematics. Yes, you can. Remember, we've talked about this the last couple chapters. Move the decimal place once over here, move it on the top. You're multiplying by 10 over 10. So this is like $700 divided by 25 stars. And then what you do is you try to reduce the fraction from there. I mean, today I'm probably okay with this answer. I'm okay with this answer, but I'm just saying that we should be thinking in terms of the same skills that we have from previous chapters. You know what I'm saying? So if we cut 700 divided by 25, I think we can actually divide the whole thing out. 25 goes into 70 twice. You get 50 here. Subtract it, you get 20. Drop a 2. 25 goes into 200. Well, it goes into 100 4 times. So 200 is double that, 8 times. Okay. So what have we figured out? We've figured out that you can expect a $28 increase over the span of the entire chart for every 1 star it increases. So that would be our rate of change. We might talk later on how this will be our average rate of change. So this is our rate of change, which is what I'm most concerned with today. This would be the average rate of change, which is maybe a future lesson. All right. I've thrown a lot your way. The only thing that's different with these last group of problems are this. This is the only difference. Slope is the rate of change. So the rate of change formula is the same as the slope formula. Slope equals y2 minus y1 over x2 minus x1. Yeah, there's absolutely no difference between the slope of a line and the rate of change of a line or the rate of change of a data set. So here's x1, here's x2, here's y1, here's y2, here's x1, here's x2. Oh no, typo! Sorry about that. Let's just get rid of that 3 that doesn't belong there. y1, y2, x1, x2, y1, y2. You know, I think I'm going to do these examples on a next video just to give you guys a little bit of a breather. So I'm coming back at you for part 3 in a bit.